Imagine an electrical design engineering challenge where the usual cost and time to market pressures coexist with the need to build equipment on which lives depend. That's the world that medical device designers work in, and like all electrical equipment, moving power and signals through cables is a fundamental part of the product. Now, safety is always a consideration, but in the medical device industry, designers must also work within a highly regulated environment. Cables have to endure everything from sterilizing agents to stray-off radiation to mechanical shock, yet the choice of cabling is often left late in the engineering design process. There are, however, good reasons to think early and hard about cable design in medical equipment. I spoke with Josh Spaulding, Design Engineering Manager with New England Wired Technologies, about the challenge of cabling in medical devices and how to spec the right product. Take a look. Some of this cabling, I'm thinking of things like EKG, ECG leads, for example. Some of these things are obviously can get tangled. They can be twisted, turned, pulled. There are right. Physical considerations there at the same time. In consumer goods automotive, where I come from, of course, there are specific standards for testing. You bend to a certain radii, you cycle a certain number of 100,000 times, and then you high pot and you're good to go afterwards. What's it like in the medical device industry? Do they work to those kinds of standards, bend radii, cycles?
Absolutely. So one of the most important things is the flexibility of the cable. So that's where bend radius is important. So a designer or medical device manufacturer should ask the question of themselves, how is the cable being installed? How is it being bent over surfaces, over pulleys? And how tight is that bend? We measure it in terms of a multiplier times the diameter of the cable. Typically for a static application, you can recommend 5 times diameter of the cable. And for a dynamic or a flexing application, 10 times the diameter of the cable. When those requirements are there, that really impacts the overall size and the materials used. We want a highly flexible jacket if that material, that product's going to be over tight bends, or if it's being installed, it's a restricted end use for UL, then it means it's installed and it's in a fixed location, and those considerations aren't as important. But you mentioned tangling of the cable. That's an important thing for medical providers. If a cable gets tangled as they're using it during operation or surgery, it's a big problem. So one of the things we do here is we provide a lubricious coating over silicone rubbers specifically that allows the cable to have a more lubricious feel. Dragging it over surfaces is a lot easier. It has a lower coefficient of friction, so it doesn't tangle as easily as a cable that would be uncoated, for instance.